Hey guys, so I'm going to go over the life tables data calculations for you right quick. So once you've got your data, you can organize it in Excel however you've got it, and you want to calculate the age at death. Once you've got that, you're going to create a table to do your calculations in. The first column is going to be the age classes. They're going to vary between each time period due to how long people are living. The next column is going to be the age group. It's going to be these columns right here. You can copy it from the appendix, the example appendix you have in Canvas, or from right here. They're in 5-year increments. So you're just going to count all the individuals that belong to each age group and put them in the next column. That's going to be the number of individuals. So there should be 50 total for each time period. The next column, little d sub x, is where we're going to scale everything up to 1,000 individuals so we can compare it to other studies. To do this, we're going to multiply everything in the number of individuals column times 5. Oh, not times 5, times 20, I'm sorry. And then once you do all of these, you should get 1,000 individuals. Normally you can drag the formula down, but it's not letting me. So I'm just going to cheat and copy the data from right here. But you just multiply everything times 20. It's pretty simple. And like you see, the total down here at the bottom is going to be 1,000. So if you're doing it right, sum your column and make sure your sample size is 1,000. This is, I forgot to say, this is data from last semester. So this isn't any of your data that you collected this year. I'm just using it for reference. So the next column is little n sub x slash little l sub x. You'll see both in different places. They both mean the same thing, which is the number of individuals alive at the beginning of the age class. From the rest of the video, I'm going to refer to it as little n sub x, but just know that little l sub x is the same thing. So to do this, the first box, the first age class, the number of individuals alive at the beginning is going to be equal to our sample size, which is 1,000. And then to do the second row, second age class, it's going to be the sample size minus the first little d sub x. It's going to be 100. And that's going to give you the second little n sub x. And then, I don't know why it's not letting me drag any of my formulas, but I have all the data right here. This is just the fancy version that I made for my appendix. This is where I did all my calculations and messed up a bunch of times before I got my final one. I'm going to do the next one to show you again. So you're going to take the sample size. So this time we're taking 900 to represent the third age class, and then subtract 20 individuals from it. And that's going to get you 880. Like I said, the numbers are going to be different for your sampling that you did during the lab this week. And then I'm just going to cheat and copy all of these down. If you have any questions about anything, if I didn't explain anything well good enough, just ask a question on Discord. I check it pretty often. Okay, so big L sub x is the number of individuals in each age class that are alive at the middle of the age class. So to do this, you're going to take the nx1, little nx1 plus the little n sub x2, and then divide it by 2. And that's going to give you the individuals alive during the middle of the age class. Still not letting me drag the formula. I'll do it one more time. So you're going to take the first, or this is the second little n sub x, add the third little n sub x, and then divide that result by 2. This is the individuals alive at the middle. And then you got q sub x. This is the proportion of individuals dying during the age class, also known as the mortality rate. You're going to be looking at this column a lot more for your results and your discussion, especially for the first age class, which is going to indicate infant mortality, and then other life expectancies, which we're going to calculate over here. So for little q sub x, you're going to take the first d sub x, 100, and divide it by the first n sub x. And that's going to give you your mortality rate, or little q sub x. And again, we're going to take the d sub x for the second age class, divide it by the little n sub x, and that's your proportion of people dying during that age class. And you should do for all of them. I'm a cheater, and I have it right here. I'm going to copy it. So little s sub x is the proportion of individuals surviving till the end of the age class. So that's just going to be 1 minus q sub x for each age class. You're going to do that. These should equal 1. So if you want to check yourself, that's how you can. I'll show you the second one. It's just 1 minus your q sub x for the second age class. And I'm going to copy the rest of them. I don't know why I can't copy formulas. Oh, wait, there it is. This one drags. This one copies pretty well, but when I did this last semester and I copied formulas down for some of the other ones, they didn't copy correctly. So if you do it, just go in and make sure that the formula remains the same, that you're dividing the right numbers together or adding the right numbers. It's pretty easy just to go through and edit up here. If you're using formulas in Excel, it's pretty easy to get them. I just canceled all my formulas, but I can't show you, but they'd be up here in this function box. You can just edit the cells that they're dividing. There's lots of videos on YouTube on how to do formulas in Excel. So if you want to know how to do it, I would check one of those out. And it's pretty helpful for considering you're going to be using it for the rest of the semester. So your big T sub x is the total number of years left for the entire population to live from age X onward. The first T sub x column for your first age class is going to be the sum of all the big L sub x. So this entire column right here. The second age class, big T sub x, is going to be from the second big L sub x onward. So it's going to be from here all the way to the end. And let me just double check that because it's giving me an error. 12 through 29. Yeah, that's correct. So for the second one, you're just excluding the first big L sub x. And then for the third one, you're taking the third big L sub x and the rest of them. And you're summing these together, not multiplying or dividing. Or I'm just going to copy the rest of these. E sub x, little e sub x is your life expectancy within each age class. So let's show you how to do that and I'll explain it. It's going to be for the first age class, your life expectancy is going to be the first big T sub x divided by the little n sub x, and then you're going to multiply that times 5. Yeah, that's fine. So that's going to get you your life expectancy for the first age class. This is the age till which each individual is supposed to live at that point. So I'm going to do it again. It's going to be for the second age class is the big T sub x divided by the little n sub x and multiply times 5. So once you've done all that, you've got your full life expectancies for each age class. And this is like how many more years they're going to live once they've reached this age class. So you're like 90 to 94, you're like maybe 2.5 years left type of stuff. So you're going to make this, you're going to do all the calculations for each time period. And then each of these is going to be one of your tables in your appendix. You need to include totals for the D sub x column, which is your number of individuals sized up to 1,000. You're gonna have totals for your big L sub x column right here, which is the number of individuals in each age class alive at the middle of the age class. And then the life expectancy. And that one is an average, not the total. Helpful hint, I changed these a lot. So just double check once you got all your calculations to make sure they're correct before you start doing your analyses, because you want to be doing your analyses with wrong numbers. Once you did that, what I did is I put all mine in one sheet so I could see all of my data at once, and I could compare like mortality rates and life expectancies. So those are your 3 tables, and then your graph is the survivorship curve graph. And what that is going to consist of is you're going to have all your age groups that occur in each time period. So some will be empty for some time periods, but post 1960, shocker, medicine got better, so people lived longer, among other things. Sorry if you can hear my dog barking, I can't control her. So these columns right here for each time period are going to be your little n sub x values. So if I go back over here, it's going to be this one right here. And these are number of individuals alive at the beginning of the age class. You're going to put all your n sub x, little n sub x for each age class, and then you're going to make a graph with them. And this is what it looks like, all pretty stuff. I'm going to show you how to make it. Not completely. So selecting all the data, into a line graph. And you get your survivorship curve looking like this if you're using Excel. It's very different from that one. So there are a couple things that I did differently than in Excel, besides changing the font and the color and removing different labels and adding other ones. But the scale is you want to change to fit the survivorship curves you can see in the textbook. You also, to get this, I'm just going to show you, because it took me like 2 hours to figure out how to just make these like this. So you're going to double click the axis, the x-axis, and it's going to bring up the format axis column. If it doesn't, you're clicking the wrong thing. So just click around until you get format axis. And then you're going to be under axis options under the bar graph picture right here. And then under labels, you're going to, instead of interval between labels, you're going to specify interval unit. You're going to make that 5. Yep, that took me 2 hours to figure out last semester. And then you're going to want to change the bounds for, you want to scale this down to make it smaller. You don't necessarily have to, but if you want it to fit how the type 1, type 2, type 3 survivorship curves look, and scale it down. And this is your third figure. If you are an overachiever like me, and you get a type 2 survivorship curve, you can use a regression to determine how your line of fit is. And that just adds to your discussion. You want more to talk about, more to write about. So if you have any questions, ask in the Discord. I check it pretty regularly. I'm also there Sundays 12 to 1. I'll be there for sure to answer questions, but I'm around if you need help. Good luck with writing.